All right, in this video, what I'm going to go over is how you would analyze data from an experiment that uses a repeated measures design in which the independent variable only has two levels. Specifically, descriptive statistics, a paired sample t-test, which you may have also heard a repeated measures t-test or within subjects t-test or a paired sample, has a bunch of different names. And then finally, to create a graph of that data. Okay. Speaking of the data that we're working with is simulated data based on a Stroop task. So just to give you a quick reminder, a Stroop task is this basic psychological task in which, say, the word red is presented in the screen, but it's either presented in red text or in blue text. And of course, it's different color words as well. And the text color and the word can be congruent, meaning that you have the word red spelled in red text, or incongruent, where you have the word red spelled in blue or yellow or green text. The participant has to indicate what color the text is. Now, typically, when it's congruent, reaction times are quicker and fewer errors are made. So in this data set, we have an ID number for the individual participants, the condition that the measurement comes from, either the congruent condition or the incongruent condition. RT is our reaction time in milliseconds. And then PE is the percent error. So what percentage of trials they actually make an error where they indicate the wrong color on the congruent and incongruent conditions. Now, just a note on how your data needs to be set up. Essentially, it all needs to match. So when we have all the congruent conditions, 2, 3, 4, 5, 6, and so on, once we hit incongruent, it needs to maintain that same order with respect to participants, 2, 3, 4, 5, 6. In other words, the paired scores have to match in terms of their order inside each condition. So let's go about how we would actually analyze this. Specifically, we're going to do this in 3 parts, where we'll calculate descriptive statistics, then we'll run a paired sample t-test, and then we will create a graph in ggplot. All right, so to calculate those descriptive statistics, we're actually going to use the describeBy function from the psych package. So the first thing that we're going to need to do is call up that package from the library. Then we need to use the function describeBy. Now, in this function, the first thing that we need to actually specify is the data we want descriptive statistics calculated on. So that would be our Stroop data, and let's go with our reaction time variable. Then the next thing we need to indicate, and I'm breaking across lines here so that it's easier to see, is what our grouping variable is. So group equals Stroop data condition. Okay, so if we were to run this, we can see that it would actually spit out those descriptive statistics for it: the mean, standard deviation, median, trimmed mean, median absolute deviation, minimum, max, range, skew, kurtosis, and standard error accordingly. Now, if we want to save these, all we have to do is set an R object equal to this function. So for example, if we want RT descriptives, we can do this same thing, and then it's actually going to save those values up here in this R object, such that if we wanted to see them again, all we have to do is print out that object. So that's how we would calculate the descriptive statistics. And just catching a glance at this real quick, it looks like our mean in the congruent condition is 700 milliseconds approximately, and our mean in the incongruent condition is 900 milliseconds approximately. So it looks like people are being slower in the incongruent condition. The question is that a statistically significant difference? To do that, we'd actually need to conduct a dependent sample or paired sample t-test. So to do this, we need the t.test function. We would want it done on reaction time. no, excuse me, the first argument we need to enter is actually a formula to specify what we want this t-test. So the first thing we need to specify is reaction time. That would be our dependent variable. We need this little squiggly line whose name is escaping me at the moment. And then we actually need our dependent variable, or excuse me, independent condition. So this tells R to conduct a t-test on reaction time with condition corresponding to the different groups. Now, R does not yet know where this data is, so we need to specify with the next argument that our data is struct data. And then we need to indicate paired equals true. And this lets R know that it needs to conduct a paired samples t-test. The default is actually an independent samples t-test, assuming that the variance is unequal. But when we hit paired equals true, that lets it know what kind of t-test we want it to run. So here we have that paired t-test. We have our t value right here. We have our degrees of freedom, and then we have our p-value. Now, when you have a very small p-value, it's actually going to report it in scientific notation. So we look at this right here, 5.671 e negative 10. That e negative 10 means times 10 to the negative 10th. So we would actually have to move this decimal point 10 places to the left. So we are very far below sort of a nominal alpha of 0.05 or even a more stringent one of 0.01 or 0.001. Now, you can save the output of this function if you wanted to. So if we wanted to save it as RT underscore T underscore test equals RT test, we can do that, and then we can actually see it's over here in the global environment. And if we wanted to see that t-test again, it'd just be printing out that R object, RT test. Now, the last thing we might want to do is actually create a visualization of this data. So we'll do that in ggplot. So the first step there is to call up ggplot. It's letting us know here that there's some functions that are named the same in both of these packages, and seeing as ggplot is the last one we called up, it's actually going to mask these functions from the psych package. Essentially, don't worry about this, okay, for what we're doing. Now, we'll need to create essentially the skeleton of our graph when we add things up in layers. So we're going to have graph 1 is equal to ggplot. Now, the first thing we need to actually indicate is our data frame that we're actually pulling this data from. So struct data. Then we need to specify the aesthetics of the graph. So what variable do we want on the x-axis? What variable do we want on the y-axis? Do we want one of the variables to be represented by a different color? So on our x-axis, we would like condition. In our y-axis, we would like reaction time. We run that. Now, it's not going to print out graph 1 just yet. We would actually have to print that out separately to see it. And here we can see that we have the bones of that graph, where we have the y-axis, we have the x-axis, and we have some basic labels, but we'll need to update them more in a little bit. Now we need to add the next layer, so add a little plus sign, and we need to add a geometric object or some type of object to represent the mean, but we don't have the mean calculated yet, so we need to use a stat summary. And we want a function of y, and that function of y that we want is the mean. And we would like that mean to be represented by a geometric object, specifically a bar. So when we do that, we can see now we have those bars that are right there, quick and easy. Okay. Now the next sort of thing that we would like to have on this graph is some type of representation of air, so to speak. So let's add another layer, which is going to be another stat summary. This one's going to be a function of the data. Specifically, we want the standard error of the mean right now, so mean SE, and we would like this represented by a geometric object as well, specifically an error bar. So we run that. Now we have error bars, and so we have something that will functionally convey the data, but it's not exactly a good graph that we'd want to send out anywhere because we have this awkward y-axis label. These error bars are kind of ridiculously huge. So let's go ahead and update the aesthetics of this graph and add some additional layers. Let's start at the top. So right here, let's look at our error bar. Let's say we want to change the color, the bar. Let's change the colors of it. So let's change the fill color and let's make it, say, a nice, let's say we're matching our school colors. A yellow, so I input the HTML code that I want for that. I now have that yellow. Okay, maybe I would like to have a border as well. And so maybe I put that border on there, and let's say I want navy blue. So I actually already have the HTML codes that I want already all picked out. So those. So now I have that border. Now for these error bars, let's make them a little narrower. So width equals 0.2 is going to make them narrow. And then I can actually add a color to that as well, so they're not just black. And let's make them match the border on that graph. All right, so we've got that taken care of. Now let's take care of updating this y-axis value right here. Y-axis label. So labs will let us specify the labels we want at each axis. So let's change that y-axis label and let's set that equal to, quotes, if I can type today, reaction time, that's in milliseconds. Oh, we need another parenthesis right there. There we go. So now we have an improved axis label. Okay. Now, we have a significant difference here. It is convention in some fields to actually indicate that significant difference on the graph. To do that, we can actually just draw a line segment right here and then add symbols to represent how significant it is, specifically what was our p-value. So to do that, the first thing we'll actually have to do is actually increase the upper end of this y-axis limit so that we have room to actually draw that bar. So we can specify another layer here, ylim, which is going to let us specifically indicate the x or the y-axis limits. So in this case, 0 for the bottom, 1050 for the top. Run that. Now we have a little bit more room. Now when we want to actually draw a line segment, again, it's another layer, and it's a geometric object. That geometric object is a segment. Now when we create the segment, we need to actually specify the x and y coordinates. So we start with the x that we want to start at, x equals 1, and then y equals, let's say here, to give us a little bit more room, that looks like 975. Oh, forgot I got to draw the other side too. And then x end would be 2, but our y end would stay the same, and that would also be 975. All right, so now we have that line segment drawn on there. Next thing we need to do is add some text right here. So that would actually be another layer. And it technically says it's another geometric object. Whatever, right? So we need to specify the x and y coordinates we want this at. We want it directly in between the bars. So x equals 1.5, and let's go y equal to, let's say, 1000 right there. So stop making mistakes today. We got our coordinates in there. Now we actually need to specify what we would want the text to be. So that would be label equals quote, and let's go with 1 star for p is less than 0.05, 2 stars for p is less than 0.001, and 3 stars for p is less than 0.001. So now we run it, we can see that we have those stars right there. Now, if we'd like them a little bigger, we can specify the size as well. Let's go with is 10. And there we have that nice, awesome graph. We can even update the aesthetics a little more by adding a theme. Let's go with theme DW. And there we have that nice, awesome graph.